Good morning, everyone. All right, so we're going to get going. I posted the solutions to 8.2 like last night at like 11 p.m. or something like that. So sorry it took me so long to get to that. I actually thought I had done it and I forgot I hadn't. So if you watch me do those solutions, you'll see that I had a lot of fun with that. Anyways, all right, we're going to start 8.3 today. So are y'all ready? This is an important section today. I remember I told you last class, I said, if there's two things I want students to come into calculus with, it's knowing the unit circle and being able to solve trigonometric equations. And so today is trigonometric equations. So make sure that you really invest some time in this section to do your homework and then really understand what's going on here. So the first part of this, I just want to get a definition, something that you'll hear me say, and I just want you to understand when I say the word what I mean. The argument of a function is the thing that's being plugged into the function. So I gave you 6 examples here. The first one is sine of theta, right? So if sine of theta is our function, the argument is theta. That's the thing that's being plugged into the sine function. Cosine of 3 theta would be the argument. Tangent of pi plus theta is the argument. And so for all of these, it's just the thing inside here. That is what we refer to as the argument of the function. It's kind of like, if you go back and you think about square roots, I don't know if you remember hearing this back in college algebra, but the thing underneath the square root has a name. It's called the radicand. That's what we call it. We call it the radicand. Well, when you're talking about functions in general, the thing that's going into the function has a name, and it's called the argument. All right. So that's just language. Let's get to this first set of 3 problems is just to give you a taste of kind of the 3 different types of ways you can be asked to solve a trigonometric equation. The first problem here, you're asked to find what's called the general solution. Now we started doing this last class, okay? So there's nothing new here today. It's just now our equations are going to get more complicated. So the first thing that you could be asked is to find the general solution. The second thing you could be asked to do is to list out, like maybe they'll say list out 6 solutions or list out 10 solutions, or they'll give you some number of solutions to find. Or you could be asked to find just the solutions between where you have a restriction. In other words, you want the answers just within a certain interval. And normally the interval that we look at is between 0 and 2 pi. So general solution, a list of solutions, or solutions just on some interval. Those are the 3 types of questions we're going to be asking here. So let's do the first one. Let me see, I may not be able to squeeze this all on here. Let me try. Okay, so going back to what we did last class, we're trying to find the solutions to this equation. So we're trying to figure out what thetas, right? What would the thetas need to be in order to make this equation a true statement? So what I'm going to do is isolate the cosine theta. I'm going to try and get it by itself. Now I want you to kind of think about this way. This equation looks a lot like 2x plus 1 equals 0. In other words, if you replace the cosine theta with x, do you all agree this looks like a linear equation from college algebra? Right? If your x was the cosine theta, right? Then it's just like a linear equation. And how do we solve linear equations? Well, we try and get x by itself, right? On one side of the equation. So that's exactly what I'm going to do here. I'm going to subtract 1 on both sides. Just like I would do here, right? And then I divide by 2. I get cosine theta is -1/2. So now, what we're going to be looking at here is figuring out when is cosine of an angle theta equal to -1/2. the argument of this function is theta, right? That's the argument. So we are trying to figure out, when is that argument? What should this argument be in order to have cosine of that argument be equal to -1/2? So we go to our unit circle and we try and figure out where cosine of an angle would be -1/2. Cosine is the x coordinate, right? And so that will happen. Who's going to tell me?
2 pi over 3.
2 pi over 3, that's here. Okay, now I can show you the x coordinate here is -1/2. And then also where else?
4 pi over 3.
4 pi over 3, that's straight, like it's down this way, right? Like this. Should I bring up the unit circle, or are y'all okay? You know, I don't think oh, there it is. I'll bring it. Okay. Just in case we need it. Right, so let me pop this thing in here. Yeah, so you can see the x coordinate here is -1/2, and up here it's -1/2, and that happens at 2 pi over 3 and 4 pi over 3. Okay, so we have two solutions so far. It's 2 pi over 3, and then if we go around like this, that would be 4 pi over 3. Now we want the general solutions, right? Or the general solution to this. So just putting 2 pi over 3 and 4 pi over 3 is not enough. You need all infinitely many answers. So this is what we talked about last class. We say, how can you get all the answers that would correspond to that point? So that means you want to be able to go to 2 pi over 3 and then be able to go around back to 2 pi over 3 infinitely many times, or go backwards, full rotations, right? So let's see, last class, I think I was calling on people, but let's see, it seems like I haven't. Is Yamna here? I don't see Yamna. How about Tyler?
I'm here,
What's going
but
on?
I'm still a little like lost, I guess.
Okay, well then good. Then maybe I can help you understand it. So do you agree right now? Well, do you understand the fact that 2 pi over 3 is a solution to this?
Yes.
Okay. Now 2 pi over 3 is one particular answer, but if I were to go to 2 pi over 3, I could also then jump back around by a full rotation, and that would still land me at the same spot, right?
Yes.
So I could have done 2 pi over 3 as an answer and then added a full revolution, and that would have also been an answer. Yes?
Yeah.
But I also could have done 2 pi over 3, and instead of going around once, I could have gone around twice, and I'd still have the same answer, wouldn't I?
Yeah.
Okay, so that means I could have done 2 pi over 3, and I could have done 2 pi times 2. That would have been 2 full revolutions.
Mm-hmm.
Or I could have gone to 2 pi over 3 and then gone around 3 full revolutions, right?
Yeah.
Or 4, or 5, or 6. So to get a general answer, it would look like 2 pi over 3 plus 2 pi times k. And so k here is always going to represent an integer. And integers are the numbers 0, 1, 2, 3, 4, 5, 6 forever. And then also -1, -2, -3. I'll list that out up here just so everyone has it. K has to come from this list of numbers. -5, -4, -3, -2, -1, 0, 1, 2, 3, forever. So Tyler, do you understand that by me putting k here, I'm saying it's 2 pi over 3 plus k full revolutions. So full revolution is 2 pi. That's why I put 2 pi there. So k is the number of revolutions I can add or subtract from 2 pi over 3, and that would give me equivalent answers.
Yeah.
Okay?
Yeah, I'm starting to get it a little bit. Yeah.
Okay, good. Now, that wasn't the only answer though, right? This point?
Yeah.
We also had this point, right, Tyler?
Yes.
Now, what's the angle that would have gotten us to this green point? What's the angle here?
It would like the angle like in degrees or
In radians. You can look at your unit circle here. I don't know if you can see that.
okay.
So we're
It
at
would
this
be
point right
the-
here,
Yeah, it would be the 4 pi over 3.
4 pi over 3. But again, we could use the same argument, couldn't we? That we could add full revolutions to it.
Yeah.
So we just, again, slap onto the end of this 2 pi times k. That make a little more sense?
Yeah.
Okay, good. So that takes care of all of our general, this is the general solution for that trigonometric equation. Is that all right, everyone? Anyone have any questions? So k can be any of these numbers, right? It can be any of these, right? Okay, now let's look at the second question. The second question says, for us to list any six solutions for this equation. So that's the same equation, isn't it? So since we've already solved this equation generally, for us to list out any 6 solutions means all we have to do is use our general solution and just pick some different values for k. We get to pick, all right? So we could let's see, let's try this. If k is 0, let's see what we would get for our solutions. So if k is 0 here, what would we get? So if that's 0, what would our answer be? 2 pi over 3, right? Right, if k is 0, we just get the 2 pi over 3. And if k is 0 here, what do we get?
4 pi over 3.
4 pi over 3. Right, so we have that's 2 solutions. We need 6, any 6 we want. So now I can let k be something else, anything I want. So how about 1? That sound good? Let k be 1. So if k is 1, think about what you're going to have to do here. I'm going to write it on the side, okay? If k is 1, then what I need to do is I need to take 2 pi over 3, and I need to add 2 pi times 1, but that's 2 pi over 3 plus 2 pi, right? Now, I need to put these together. And how do we put these together? How do we put 2 fractions together?
You need a common denominator.
You need a common denominator. So I would need to put a 1 down here, and then I'd need to figure out what my common denominator is, right? And then I would have to do the same thing on this one, wouldn't I? When I do the 4 pi over 3 and let k be 1, I have to get a common denominator and put them together. And then if we let k be 2, I'm going to have to do it again and put them together, common denominator. Yes? You understand? So if we do a lot of these, we're going to have to do common denominator over and over and over and over. So the reason I'm saying that is because I don't want to have to do the common denominator over and over and over. So what I'm going to do is I'm going to take my general solutions here, and I'm actually going to find a common denominator now. This is a very important, I'm not going to call it a technique, kind of a process that you can do to keep yourself from having to do common denominators over and over and over. All right, so let's take that first solution. Let's get a common denominator here. So I'm put this over 1. And now what would the common denominator between these 2 fractions have to be?
3.
3. So I multiply the top and bottom here by 3. And what we get is 2 pi over 3 plus, let's see, 2 times pi times k times 3. The 2 times 3 becomes 6. I have 6 pi k over 3. And now that they have the same denominator, I can put the numerators together, 2 pi plus 6 pi k all over 3. I'm running out of room. Okay, so be careful here. 2 pi plus 6 pi k, you cannot combine those together. These are not like terms, right? These are not like terms. One of them has a k, the other doesn't. Now, this is my new kind of general solution written with a common denominator for that first one. Let me do the same thing on the second one. If I take theta equals 4 pi over 3 plus 2 pi k, and I write 2 pi k as a fraction, and then get a common denominator, multiply top and bottom by 3 again, I'm going to get theta equals, let's see, 4 pi over 3 plus again 6 pi k over 3, and then I put the numerators together, I get 4 pi plus 6 pi k over 3. That's my second general solution. Do you all understand that what's here in these two blue boxes are exactly the same as these answers here? I've just put them together with a common denominator. It just looks different, but it represents the same answers. Now watch how quickly you can get answers now. Okay, if you're willing to do this little work right here, watch how easy it is to figure out 6 solutions. So let's go back to this. K is 0. If k is 0, if I replace this k with 0, right? This is gone then, and I just get 2 pi over 3. If this k is 0, then I get 4 pi over 3. And those are those two answers. Now let's do k is 1. So let's see, Maddie, I think you're up. Maddie, what do you get if k is 1 here?
You get 8 pi over 3.
8 pi over 3. Everyone see that? You just replace k with 1. That becomes 6 pi. 6 pi plus 2 pi is 8 pi over 3, and we're done. We have one answer, 8 pi over 3. What about the other one, Maddie?
That would be
The other
10 pi
box.
over 3.
I'm sorry?
10 pi over 3.
10 pi over 3. So again, you replace this k with 1. You get 6 pi times 1 is 6 pi plus 4 pi. That's 10 pi over 3. And that's it. Do y'all see what I'm saying here? Like, we didn't have to get a common denominator. It's already done for us. Okay, if k is 2, well, you know what? 2 seems pretty natural, right? To do 2 next. But we can do anything we want. So I'm just going to make this fun. Let's go k is -4. So if k is -4, let's see what we would get. So if k is -4 here, Maddie, you want to do this one too? K was -4. What would you get?
Negative 22 pi over 3.
-22 pi over 3, exactly, because you put -4 here, you get -24 pi, you add 2 pi, that gives you -22 pi over 3, and then the other one would be what?
Negative 20 pi over 3.
-20 pi over 3. See, it said any 6 answers, so we could pick any values we want for k.
I do have one question though.
Yes.
When it says any 6 solutions, does that mean we pick 3 values for k, or does that mean we pick 6 values for k?
It just wants 6 solutions. So 1, 2, 3, 4, 5, 6.
Okay.
We could have, Maddie, what we could have done is just looked at this one and ignored this. We could have just done 6 solutions here and done like 6 different k's for this one. It doesn't tell you which, it's not saying, it doesn't care which of these it is. It just has to be a solution to the original equation. All right, any questions before I move on to the next part? Okay, the next thing said, find the solution or solutions for this equation on the interval 0, theta is between 0 and 2 pi. And it was the same equation. Right, that is the equation, right? Yeah, that was it. So same equation. Find just the answers between 0 and 2 pi. So this is where you would have to kind of look at your general solutions. I think I'm going to go grab my general solutions real quick. Let me grab those. Okay, here are our general solutions. And so what we'd want to do is try and pick K's so that we get all the solutions that are between 0 and 2 pi, right? So you'd have to, you'd have to start thinking about this. Like if K is 0, we already know that we got the two answers, 2 pi over 3 and 4 pi over 3, right? Are those both in this interval between 0 and 2 pi? Well, they're both positive, right? They're both positive, so you're definitely greater than 0. Now, are they smaller than 2 pi? Are both of these smaller than 2 pi?
Yes.
How do you know?
Aren't they set up as like a fraction, so they would be less than 2 pi?
Yeah, so look at the number here divided by the number here. 2 divided by 3. 2/3 is smaller than 2, isn't it? So the way I think you should look at this is you have 2/3 times pi. And you're trying to be smaller than 2 times pi. So as long as this number here is smaller than 2, then this is true. Same with this next one. This one is like 4/3 times pi. 4 divided by 3 is about 1 point something. That's still smaller than 2. So we're good here, right? Those are two answers. What if K was 1? Now we already did this on the previous, right? What was it when K was 1? 8 pi over 3 and 10 pi over 3. So we got 8 pi over 3 and 10 pi over 3. Are these smaller than 2 pi? Look at the fraction in front.
No.
8 over 3. 8 divided by 3 is like 2 point something, isn't it? Right? 3 goes into 8 more than 2 times. So this is too big, isn't it? This is too big. Same with 10 over 3. That's 10 divided by 3 is bigger than 3. So these are both definitely bigger than 2 pi. Understand? So these are not going to work. Now, you may think you're done here, but you're not, because we know that if we do K equals 2, it's going to keep getting bigger, but we haven't tried any negatives yet. So what if K is -1? We haven't tried that, have we? So let's do it here. If K is -1, let's do it into this one here. If this is -1, we get -6 pi plus 2 pi. That should give us what? -4 pi over 3. And if we do -1 right here, we get -6 pi plus 4 pi. That's -2 pi over 3. Are these two answers within this interval? Are they?
No, because
Why not?
the
Because
zero.
of the negative.
They're negatives, right? And to be here in this interval, we wanted our theta to be bigger than 0, and bigger than 0 means you have to be a positive number. So it can't be these either, which means that the only two solutions we have are these two. Now you might be saying to yourself, why do we have for this third part, why do we have to go through all that work when we could have just looked at the picture and saw the only two answers we had were 2 pi over 3 and 4 pi over 3, right? Doesn't it seem like it would have been just easier to just look at the circle, right? Okay, here's why. Here's why I didn't do it that way. You ready for a new problem, a harder problem now? We're going to do it. Okay, so let's do this. For this first part, let me give you the equation first. We want to solve this. So let's solve the equation. Let me just make this up real quick. I'll keep it somewhat simple. -2 sine of 4 theta. We'll start with that, okay. +1 equals 0.
That is one question I have.
Yes,
Is the +1 considered part of the argument, or is it just the 4 theta?
good question. The +1 is not part of the argument, and you can tell because of the parentheses around the 4 theta. Now, if it had been written this way, that would be considered bad notation. Okay, that would be considered to be like not using proper punctuation, or when you're writing a paper, like periods and things like that. This is just, you should never write something this way, because it's hard to tell, is it just the 4 theta in the sign, or is it the 4 theta plus 1? If I wanted the plus 1 in there, I should technically write it like that. And if I don't want the plus 1 in there, then I do it like this. You see the difference? Yes, Maddie? Yeah, okay. All right, so here we go. By the way, what is the argument?
4 theta.
4 theta. Okay, that's different. The last time it was theta, wasn't it? Not 4 theta, it was theta. Okay, let's see how that impacts things. I still want to kind of see that this looks like a linear equation. This almost looks like -2x plus 1 equals 0. And so I'm going to solve it like I would a linear equation. I'm going to move the 1 to the other side. When I move the 1 to the other side, it becomes -1. I divide both sides by -2. And when I divide both sides by -2, I get +1/2. All right. And I didn't tell you what I wanted you to do here. I forgot, I got distracted here. First thing I want to do is I want to find the general solutions. Second thing I want you to do is find 6 solutions, any solutions you want. And the third thing I want you to do is find the solutions just between 0 and 2 pi. So same 3 problems that we did before, we just have a new equation. All right, so the argument is 4 theta, right? We are really looking here, we're saying sine of some angle has to be equal to 1/2. So we're going to go to the unit circle. Sine is the y coordinate. Oh, I'm just going to go grab my unit circle. Sine is the y coordinate. And we're trying to figure out where's the y coordinate 1/2, right? So that happens here and here, 2 places. Those 2 angles are what?
Pi over 6.
Pi over 6 and 5 pi over 6. Now, be real careful. Be real careful. We are not saying that theta needs to be pi over 6 or 5 pi over 6. That's not what we're saying. What we're saying is that the argument has to be pi over 6 or 5 pi over 6. That's something different, right? Because our argument is 4 theta. What we're going to have to write down here is that 4 theta has to be pi over 6, or 4 theta has to be equal to 5 pi over 6. Y'all understand? It's the thing that goes in here after you multiply it by 4, that angle needs to be pi over 6. And then whatever you plug in for theta, after you multiply it by 4, it has to be 5 pi over 6. Not only does it have to be pi over 6 or 5 pi over 6, we need to write pi over 6 in its general form. That means you need to be able to come back to back to a pi over 6. So what am I going to add to the outside of this to get my general solutions? If I need to get back to this blue pi over 6.
2 pi.
2 pi.
K.
K. All right. And then the same thing on the other one. 2 pi. K. Any questions? Now let's solve for theta. Let's get theta by itself. So to get theta by itself, I'm going to divide everything here by 4. So I divide this side by 4, this side by 4, or this by 4, this by 4, this by 4. And I get theta equals pi over 24 plus pi k over 2. Don't understand what I did there? When you divide pi over 6 by 4, it just, the 4 multiplies with the 6, becomes 24. And then 2 over 4 gives me a 1/2. So I put the 2 on the bottom. Let's put these together with a common denominator. Common denominator between those two would be 24. So I'm going to multiply top and bottom here by 12. And I get, let's see, pi plus 12 pi k over 24. That is my first general solution with a common denominator, which is going to make our lives easier when it comes to the second part of this problem. On the other one, I divide both sides by 4 again. I get 5 pi over 24 plus pi k over 2 again. I get a common denominator, so I multiply top and bottom of this one by 12 again. And I get 5 pi plus 12 pi k all over 24. Are there any questions? Come on, y'all. This is important stuff. This is the time to ask.
Can you reduce the fraction between the 12 pi k over the 24 for?
You cannot. You cannot, because it would have to be something that reduces from all three.
Oh, okay.
The only way to reduce it is to split it into 2 fractions, and then you could reduce, but then you get back to where you started,
Oh, okay. I see. that.
right? So we want to keep it as one big fraction because it makes the plugging in of k easy.
Easier. Mhm.
Yeah, good
Okay,
question.
thank you.
Is everyone also comfortable with the idea of why 5 pi plus 12 pi k can't be put together into like 17 pi? It's because this has a k and that doesn't, right? Okay. So this answers number 1. This is the general solution, both of these. Now, for number 2, part 2, I need 6 solutions. So I'm going to do k equals 0. That should give me 2 answers if I do them in each one. K equals 1, and I'll do k equals, let's do -1. You can pick any k's you want. So if I let k be 0, I forgot to mark people off here. Oops. Caroline, you there? Kind of losing track of things here.
Yeah, I'm here.
You're here. You following okay?
Yes.
Okay. I called on Tyler. Forgot to mark this down. I was just going to ask you what you get when you plug in k equals 0. Caroline.
We, k plus 0, that would be pi over 24.
Pi over 24. That's you plugging into that one, right?
Yes.
To this one right here.
Yes.
What about this one if you do k is 0 here?
That'd be 5 pi over 24.
5 pi over 24. So you've got 2 solutions so far. You need 4 more. So Caroline, what happens if you do 1 in for k?
It would be the same without the k. It'd be pi plus, or no, it'd be 13 pi over 24.
13 pi over 24. And then the other one would be what?
17 pi over 24.
17 pi over 24. Good. And let's see, Leslie, is Leslie here?
Yes.
Okay, Leslie, what do you think? How about for k is -1? Are you understanding what we're doing, Leslie?
Yes. So
If k is -1, what would you get?
-12. So -11 pi over 24.
Mm-hmm, good. And the other one?
-7 pi over.
-7, good. -7 pi over 24. All right, we've got 6 answers. Okay. Good, good. All right, third one. We want the answers just between 0 and 2 pi. All right, so let's look at the answers that we already got. Is pi over 24 between 0 and 2 pi? Well, it's positive, right? So it's greater than 0. The number in front of pi is a 1, and the number on the bottom is 24. So 1 divided by 24, is that smaller than 2?
Yes.
Yes. Okay, what about the next one? 5 over 24, is that smaller than 2? Yes. So those two answers will be here. How about 13 over 24? That's smaller than 2? Yes. 17 over 24? Yes. Crap, there might be more, right? There might be more. Now, how about the negatives here? K's -1 won't work because these are negative answers. So far it's these four, okay? It's pi over 24. It's 5 pi over 24. It's 13 pi over 24. It's 17 pi over 24. And what do you think I should try to get more? What should I do to get more answers? Because it looks like there's going to be more.
A 2.
Let K be 2, right? What would happen if K was 2? Let's try it out. I'm going to do it right here. If K was 2, let's see what answers we would get. 2 here, that's 20. 2 times 12 is 24 plus 1, that's 25. Oops. That's 25 pi over 24. Is that 25 over 24? Is that less than 2? Yeah, 25. You can do it on your calculator if you don't know. Like 25 divided by 24 is a little bit bigger than 1. Okay, if K is 2 into this one, we get 24 here plus 5, that's 29 pi over 24. 29 divided by 24 is still less than 2. Okay, so now I need to try K is 3. If K is 3, I've got 3 times 12 is 36 plus 1 more pi is 37 pi over 24. Is 37 divided by 24 smaller than 2?
Yes.
Still smaller than 2. Okay. Now I plug in 3 here. 36 plus 5 is 41 pi over 24. 41 divided by 24 is still less than 2. My goodness. Okay, so I keep going. K equals 4. So if K is 4, let's see what we got. 48, is that right? 48 plus, so 49 pi over 24. And that's where we finally get bigger than 2. 49 divided by 24 is bigger than 2. So this solution won't work. Make sure you check the other one. 48 plus 5, that's what, 53? Yeah, that's going to be too big. 53 pi over 24. 53 divided by 24 is too big. So any questions on that? Like how I'm looking at the coefficients, like 37 over 24, 41 over 24. That's what I'm looking at to see if it's less than 2, right? 1 over 24, 5 over 24, 13 over 24, 17 over 24. Just looking to make sure that that ratio always stays smaller than 2 pi. So how many solutions do we have between 0 and 2 pi? Let's see, 1, 2, 3, 4, 5, 6, 7. We have 8 solutions within that range, 0 to 2 pi. That is why it is so important to understand what's happening with the argument. Because if you don't pay attention to the argument, you might think that there's only 2 answers between 0 and 2 pi. You say, oh, pi over 6 and 5 pi over 6. Totally incorrect. Because the argument was 4 theta, we actually have 8 answers. Now, if you don't believe that this is true, I'm just going to pick one of these answers, okay? Let me just pick one of these. I'm going to pick that one right there. I'm going to take that and plug it into the original equation. Now, the original equation was, let me just grab it here. Here's our original equation. Just to prove to you that we did get a solution, what I'm going to do is I'm going to do in here, I'm going to replace, it was 4 times theta, right? And I'm saying theta is 41 pi over 24, right? Like that. Right, that's what this is. So let's see what happens here. If I reduce, do you see 4 goes into 4 once and 4 goes in here, what, 6 times? So this becomes -2, sine of 41 pi over 6 plus 1 equals 0. Okay, this is going to be hard to show, but I've got to go around. This is pi over 6 41 times. This can be hard to show it, but let me try. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. So if I go around one time, that's 12 pi over 6. Do y'all agree with that? If I just do one full revolution, that's 12 pi over 6s. What if I go around twice? How many would that be? Go around
24.
twice, it'd be 24 of them. If I go around 3 times, it would be what?
36.
36. So if I go around 3 times, that's 36. I need to get to 41 of them. So imagine that I've gone around 3 times. And now I'm at 36. So I've gone around once, twice, 3 times. I'm at 36 pi over 6s. Now 37, 38, 39, 40. Okay. 41 would put me down here, right? So 41 is right here. So here's where I am. I'm right here at this point. The coordinates of that point are negative root 3 over 2 and 1/2. So sine of that angle is the y coordinate there, which is 1/2. And then plus 1 equals 0. If I do negative 2 times 1/2, that's negative 1, and then I have plus 1 equals 0, and that is true. All I was doing there is showing you that as crazy as 41 pi over 24 sounds, it is a solution to this original equation. And that solution lives between 0 and 2 pi. Okay, we need to move on, yes? I'm hoping you get the idea here. So what I'd like to do now is show you problems that are out of the homework. Okay. These are problems that now, this is out of the textbook. Like this is what the problems look like in the textbook. So the problem we just did is similar to this right here. Something like that. Let's do something a little more complicated. So I'm going to let you look at these. And for right now, I'm going to let you only pick between 13 and 22 right now. Somebody pick a problem that they're looking at and they're like, oh, that looks scary. And we'll do
22.
that. 22? You want to do 22?
Mm-hmm.
Okay, we'll do 22. All those square roots and everything kind of freak you out a little bit?
Yeah.
Yeah. Okay, so look what it's asking for. Solve each equation on the interval 0 to 2 pi. That's all they want here. All right. That's what they want. So I'm going to treat this like a linear equation. Because I mean, this is like a number, that's a number, and then this is kind of like my x. And so, you know, in some way, this looks like 4x plus, I don't know, 3 equals 5. It's just a bunch of numbers and then a number in front of the thing we're trying to solve for. So I'm just going to start moving things around. So I'm going to subtract. I'm going to subtract 3 root 3 on both sides. Since this was added over here, I subtracted it on the left and I subtracted on the right. Interesting question. Can I combine these? Can the square root of 3 be combined with minus square root of 3?
Yeah, because you can
Yes.
the root.
What does it become?
Root 3 is like their own number,
The root 3s are almost like a variable. It's almost like this is x minus 3x because they're the same exact radicals. So what would this turn out to be?
Negative root 3 over 2.
Negative. This is one of these roots. So I have one of those roots here, and I'm taking away 3 of those roots.
Oh, sorry, I jumped ahead. It would be negative 2√3.
Okay, I see what you did. Yeah, I'm with you now. Okay, so when you put those two together, it becomes negative 2√3. Now to get sine theta by itself, I divide both sides by 4. So sine theta equals, oh, that reduces, right? The 2 goes into once, 2 goes in here twice. So we just get negative √3/2. That should look familiar, shouldn't it? Right? That should be something you're comfortable with, I'd hope, by this time. I mean, remember from the beginning of this class, I've told you all that you need to understand this unit circle very well, right? Are you seeing why it's so important to understand this circle? It's like never going to go away. It's always going to be here. So the more comfort you have with this, the easier this is going to be for you. So we want to know when theta, our argument here is theta, we want to know when we get negative √3/2, and sine here corresponds to, well, I'm not even going to say, I'm just going to ask someone to tell me. Let's see. Who have I not called on? Seems like So Young, are you there?
Yes, I am.
Okay, so tell me where to go from here.
Divide pi over 3.
So theta is 5 pi over 3. Where's that? 5 pi over 3 is here. The y coordinate there is negative negative √3/2. I agree with you. 5 pi over 3. Is that the
And
only?
4
Go ahead. And
pi
what?
over 3.
And 4 pi over 3.
4 pi over 3. Mhm.
I agree. That happens here, and here are y coordinate. Now, those are the only two answers between 0 and 2 pi, right? But the only reason I can say that is because our argument is theta. Had it been like 4 theta or 3 theta or anything other than just theta, I would have to go and do what we did in the previous problem, right? So I would have to go through and get my general solution. So me personally, I always like to get the general answer. Even if the problem is only asking me to do, 0 to 2 pi, I personally like to always just get the general answer, plus 2 pi k, plus 2 pi k. I always like to get them and put them together with a common denominator. I'm not showing this step, but I got a common denominator there. I just did the second fraction by multiplied by 3 on top and bottom. This is my personal preference. I feel safer when I do it this way. Once I get the general answers, I start doing k equals 0, k equals 1, k equals 2, and I keep doing it until these numbers get too big. Am I making sense what I'm doing? So if k is 0, I get my two answers, 5 pi over 3 and 4 pi over 3. That's what So Young got us, right? And then if I do k is 1, let's see, if I try 1 in here, I get 11 pi over 3. And 1 in here, I get, 10 pi over 3. And those are too big. Do y'all see those are too big? 11 over 3 is bigger than 2. 10 over 3 is bigger than 2. So I have just these two answers. If I try k is -1, I didn't do it, but if I try k is -1, I know I'm going to get a negative answer here. It'll be negative 6 pi plus 5 pi. That'll be negative. And then here, negative 6 pi plus 4 pi. That's negative. So your only two answers are these two. Okay, let's do another one. Where is it? Oh, here we go. Somebody else pick another one between 13 and 22.
17.
17, is that what you said? Okay, so 17, tangent theta plus 1 equals 0. here we go. This really means tangent theta has to be -1. Where is tangent? Where is the tangent function equal to -1?
3 pi over 4.
Okay, so at 3 pi over 4, if you take tangent, that means you take the y coordinate and divide it by the x coordinate, you should get -1 because they have the same x and y coordinate, they just differ by a sign. Anna Marie, is that the only place?
Also at 7 pi over 4.
Also at 7 pi over 4. Because again, the y and the x coordinates are the same, they just differ by a sign. So Anna Marie, what would the general solutions be for theta? The argument, right, has to be equal to, what would it be?
3 pi over 4 plus 2 pi k.
Plus 2 pi k. I agree, that would give you all those. And then you could also do the same thing on this, right?
Yes, sir.
Now, Anna Marie, do you remember from last class, there's a shorter way to do it because these two are directly across from one another? Do you notice how they're directly across from one another?
We could do 3 pi over 4 plus pi k.
Plus pi k. So because, and this is only because these are directly across from one another, you can start out at 3 pi over 4 and then start jumping by pi's to get, pi is a half rotation. So you can jump by half rotations back and forth, and that will cover all of these solutions. Tyler, does that make sense? Because I know you're having a little bit of issue with the whole idea of jumping around.
Oh, no, yeah, I'm good.
You're good with that now? Okay.
Yeah.
Good. So do y'all see our general solution only has one form? I mean, that's it. We're done. This covers everything. Now, we need to figure out which answers are between 0 and 2 pi now. Okay, so let's just, oh, well, I need a common denominator. Oops, forgot that. So I do 3 pi over 4 plus 4 pi k over 4. So there's my common. And that gives me 3 pi plus 4 pi k all over 4. There's my general solution. And now I'm gonna start cranking out some k's. I don't know how far I'm gonna have to go. Okay, if k is 0, I get 3 pi over 4, right? That's it. K is 0. If k is 1, I get 7 pi over 4. What if k is 2? 11 pi over 4. Should I keep going or no?
No, because that's too big.
That's too big. Yeah, I'm done here actually, because this right here, 11 over 4, that's too big. 11 divided by 4 is bigger than 2, so I can stop there. Should I check some negative values? I should maybe just check one. Let's just check one. If k is -1, what do you get? Negative pi over 4, right? That's not going to work because can't have a negative number. So my only answers are these two. Questions? No? All right. I think I'm gonna do number 26. Okay, do number 26. I'm going to help get it started, and then maybe I'll let you try and see if you can finish it. So for 26, I have a cosine squared theta, right? So I need to take the 3 to the other side, add 3 to both sides. I need to divide both sides by 4. And then I need to do what?
Square root.
Square root. So we have to take the square root of that And the square root of that. Now we have to do plus or minus. We have to do plus or minus because we took the square root. So we get cosine theta is finally isolated, and we get plus or minus. Now, when you do the square root of a fraction, you can do the square root of the top over the square root of the bottom, and the square root of the bottom is just 2. And the reason I did that is because we should recognize that, right, as one of our common points on our unit circle. So let's see. Lauren, did I already call on Lauren? I feel like I did. Lauren? No? I don't see Lauren here anyway. How about Brianna?
Hello,
Oh, how's it going?
I'm good.
Good. Okay, Brianna. So can you tell me what the argument must be equal to here?
The argument is theta, right?
Mm-hmm.
So you're looking for the numbers in the unit circle?
I'm looking for the angles that would spit out
Right.
this number for cosine. So where did, just
So,
tell me where they occur. Point me to the angles first.
I've got pi over 6.
Pi over 6. Okay, I agree, because there your x coordinate is positive root 3 over 2. Go ahead.
And then I have negative, or not negative, I have 5 pi over 6.
5 pi over 6 also, because that would give you the negative one. Okay, keep
Right.
going.
7 pi over 6.
7 pi over 6, because that would give you that one.
And then 11 pi over 6.
Okay, 11 pi over 6. Great. Okay, now, Brianna, is there an easy way for us to, can we start out like at pi over 6 and then like jump to the next one, or is it, I'm not going to be able to do that?
You can't do it like that.
Can't do it because there's not an equal jump between these, right?
Right.
But the pi over 6 and the 7 pi over 6 are directly across from each other. So
Right.
you can jump from this one to this one and then back, right?
Yes.
How would you do that? Tell me what I would write here.
Oh, let's see. So,
Give me where you want to
Alright.
start.
well, pi over 6,
Okay, and then how much are you going to jump by?
pi, so it'd be plus pi k.
Yep, plus pi k. Everyone understand that? That was from last class, but I know sometimes it takes a little time for this to sink in. Okay, Brianna, great. That'll take care of those two. What about the other two?
I did 5 pi over k, or 5 pi over 6 plus pi
Mhm.
k.
Plus pi k. Good. So that means start out at 5 pi over 6 and then again jump, because the other one's directly across, jump by pi k.
Yep.
All right. I'll ask you one more thing, and this is just more to see how you feel about this. Can you get common denominators for those?
Yes.
Okay.
So, sorry, I like to write it out.
No, yeah, if you need to write it out, write it out. You're gonna do.
So I got 6 pi
Mm-hmm.
pi plus 6 pi k over 6.
Yeah.
And then I got 5 pi plus 6 pi k over 6.
That's it. Excellent. Good job.
Thank you.
Okay, next up, let's see here. Jordan, did I call Jordan yet?
Now you have it.
Okay, Jordan. Jordan, are you following this?
Yes, I am.
Okay, good, good. All right, so I got the general solutions because that's just like, I just like to do that. That to me is like the most powerful answer you could have, is all the answers. But we only want the ones between 0 and 2 pi. So what are we going to do to find the ones between 0 and pi, 2 pi now?
Start plugging in the K's.
Yeah, start plugging in k's. Okay, so let's start. I like to start with k is 0. So tell me what answers I get when I do k is 0.
Pi over 6 and 5 pi over 6.
Okay, good. And then if k is 1,
7 pi over 6 and 11 pi over 6.
okay, I'm just going to keep going until you tell me to stop. K is 2,
8 pi, no, 12. 13 pi over 6.
13 pi over 6,
which is too big.
That's too big, yeah, because 13 over 6 is too big. Okay, and then let's just check the other one just to make sure. I think that's what 2 goes into there. 17 pi over 6? No good, right? Now, you should also check k is -1, just to make sure there's none the other direction. So if k is -1, yeah, it's not going to work. Either one, because you'll get -5 pi over 6. You'll get negative pi over 6. So no, neither one of those works. Does that make sense, Jordan?
Yes.
Okay, good.
Professor, I have one question. So
Mhm.
why do we check for the negatives just to make sure it doesn't go the opposite direction?
Because it is possible, it is still possible to get, just because we plug in a negative k does not always mean we're going to get a negative angle. There are problems that may come up where you plug in k is -1 and you get a positive answer. It would depend. See, when Brianna did this earlier, she said, okay, I'm going to use 5 pi over 6, right? Or sorry, yeah, for this one. So I'm going to start at 5 pi over 6 and then just jump by pi each time. There's nothing that says that Brianna couldn't have gone backwards and used a negative angle to start and then started jumping by pi's. And if she did that, then k being negative might actually work. So you just need to check it. That's all. Just check it once, and if it fails on the first one, you don't have to worry about the others. Okay, I think we're ready to turn the screws. Have y'all heard that expression before? Turn the screws. Have I mentioned that to you before?
That means it gets harder, right?
What's
No,
that?
I heard that.
That means the problems get harder.
Yeah, but do you know where it comes from? I think it comes from like medieval torture. When they used to like torture people, they did lots of things to torture people in the past. One thing that they would do is they'd like put a person's head in between like 2 wooden blocks, like a vice, and then they'd start turning the screws to, put pressure on their heads, and they'd be like, tell us what you know, or declare your allegiance to the king, whatever it is, and then they just keep turning the screws. It just become worse and worse and worse. So we're going to turn the screws now. All right, we're just going to make this a little bit harder. And I think I'm ready to jump to something significantly more difficult. So I think I'm going to jump to this one. So for this one, I'm just going to ask for the general solutions. Okay, just the general solutions. If you look back on every problem that we've done up to this point, we've treated them like linear equations, and we have isolated the thing we're solving for. Like here, we moved the 3 over, we divided by 4, we took the square root. The one before that, we brought the 1 over. The one before that, here, it was like linear. We brought the 1 over, we divided by -2, and we got the sign by itself. Do y'all see that we can't do that here? You can't get sine by itself because you have 2 of them. You have a sine squared and a sine theta. But if you squint your eyes, just squint them just right, do y'all actually see this looks a lot like this? Doesn't that look like a quadratic equation? Like if x was sine theta, then this looks like 2x squared minus 2x minus 1 equals 0. And so how would you factor, I just gave it away. I meant to say, how would you solve this? You would factor it, wouldn't you? And you would try and see, can I factor that out to be this? And you remember when you were in college algebra and they're like, you need to know how to factor, like it's always going to be there. Well, this is why, because now we're in pre-cal and we need to be able to factor to solve this problem. So we have to be able to break this down. And because this is not a college algebra class, I'm just going to assume, even though I know that this is going to be a trouble for some of you, that you could break this down into you could factor this into 2x plus 1 times x minus 1. If you're having trouble on this step, again, you're going to need to get some help on that, whether it be with me or a tutor, to be able to factor this. Questions, comments, concerns, complaints? So I'm now going to break this down over here into something times something equals 0. But it's going to be this factorization, but x is going to be sine theta instead. So there's going to be 2 sine theta plus 1, and then this other one's going to be sine theta minus 1. Does that make sense to everyone? We're just breaking that down. We're treating it like a quadratic equation. We're factoring it. And now once you factor, what do we do in college algebra once we factor? What do we do to each factor?
We
Set
set
it
them up
equal to
as
zero.
their own equation.
Set them to 0, right? That's what we do. We set those each equal to 0. So that's what we're going to do now. We are going to take this and we're going to have 2 equations that come up now. The first equation is 2 sine theta plus 1 equals 0. And the other one is sine theta minus 1 equals 0. Those 2 individual equations must now be solved doing what we were just doing before this problem. So on the first one, I'm going to move the 1 over, makes it -1, and I'm going to divide by 2. Did I do that fast? Too fast, or is that okay? Move this 1 over, it comes -1, then divide the 2, we got -1/2. On the other one, move the 1 over, add 1 to both sides. Okay, so watch this. You ready? Here we go. Sine theta is -1/2. Quick unit circle. Sine is the y coordinate. Where is the y coordinate -1/2? Here and here. Right? I take the argument theta. Let me talk about, or let me get this first solution here, this one right here in red. That is the angle what?
11 pi over 6.
11 pi over 6 plus 2 pi k. I do 2 pi k because I want to be able to get back to this point, keep on adding full revolutions. And these two are not directly across from one another, so I can't jump from one to the other. So that's one set of answers. The other set of answers is going to be this green one. Oops. The green one, and the green one is the angle
7 pi over 6.
7 pi over 6 plus 2 pi k again. That'll give me all the general answers for that one. And we are halfway done. Now we go to the other one. Sine is the y coordinate. Where is the y coordinate equal to 1?
Pi over 2.
Pi over 2. So my answers for that one are theta must be pi over 2 plus full revolutions to get back to it. There we go. We have 3 sets of general solutions here. Now I could start letting k be 0, 1, 2, or -1, -2. I can get you all the answers you want. If I wanted just the answers between 0 and 2 pi, right? If I'd asked for that, then you would now have to start plugging in k equals 0, checking to see. Oh, well, you know what? You probably want to get a common denominator, right? And then start checking. So in the homework, let me see. In the homework for these problems, they want them on 0 to 2 pi. So there would be more work to do. Oh wait, hold on. No, those weren't the problems. It was these. Yeah, it was this. Yeah, they do want it between 0 and 2 pi. So I'm going to stop here for this problem because I hope you know what to do here. Common denominator, common denominator, common denominator, then k is 0, 1, 2, 3, and then just go until it gets bigger than 2 pi, right? I want to give you one to work. That's why I want to put you in breakout rooms and see what happens. So I'm going to give you these two. So take a moment to write both of these problems down. And then I'm going to put you in breakout rooms and let you work together. Number 64 is very similar to the problem we just did. Number 67 is going to require a light bulb to go off in somebody's head. So we'll see if somebody can get the light bulb to go off. Just the general solutions, okay? Give me the general on these, the general solutions, but with common denominator. So go ahead and put the answer, the general solution, put the 2 pi k or whatever you do, if it's pi k, 2 pi k, whatever it is, put them together. And I'm going to give you about, I don't know, 7, maybe about 12 minutes. Everybody have those copied down? Okay, here we go. Breakout rooms. And you're just going to be randomly assigned to a breakout room. I'm going to go 3 to 4 people in each room. And I'll bring you all back in here in about 12 minutes. I want you to at least get the first problem done. Here you go. Enjoy. Okay, we're gonna just wait another 10 seconds for everyone to get back in here. Okay, I think everyone's back. So here's the solution to the first one. You had to look at it as a quadratic and then factor, just like the previous problem. So are there any questions on that one? Okay, so you have 3 general solution sets, and I got the common denominators for this. All right, and then if you were asked for the answers between 0 and 2 pi, of course, you'd have to just start checking different k's. All right, how about the second one? That's the one that I think some of you had an opportunity to look at. I know, Cameron, you said that you felt like you got it. Did anyone else feel like they have it? Cameron, you want to share what your thoughts are on this one?
Yeah, if I remember correctly, I think the sine squared of theta minus cosine squared of theta, I think that's an identity. Which is
Okay, so you're thinking identities, right? Which is what you should be thinking here. That's good. Now, I didn't expect people to get this, but we had a Pythagorean identity way back earlier in this class that said this: sine squared theta plus cosine squared theta equals 1. That is a huge identity that everyone here needs to know. All right. So notice in this equation that we've got cosine, cosine, and then we have a sine. The sine seems out of place, doesn't it? Like, we'd rather work with all cosines or all sines, but not a mixture of sine and cosine. So notice on this equation, the Pythagorean identity, you could subtract cosine squared theta from both sides. And so you get this new identity that says sine squared theta is 1 minus cosine squared theta. Do y'all agree with that? So if I now rewrite the problem and I replace this, so Cameron, you were thinking that this was an identity, like these two together?
Yeah, I was gonna say it was equal to 1, and then I was gonna move the 1 over so the ones cancel out. Like, that's how I did it, but I forgot that it had to be a positive.
Has to be a plus. So good. At least you were thinking identity. That's good. But because it wasn't a plus, we can't. But we can replace the sine squared theta with 1 minus cosine squared theta. Okay, so that's what this gets replaced with. And then everything else I'm just going to write. Minus cosine squared theta equals 1 plus cosine theta. And what's good about this is now everything is in terms of cosine. And I can put these two together because those are like terms. So I have the 1 minus 2 of the cosine squared thetas equals 1 plus cosine theta. And now we have, again, a quadratic, just like the previous problem that you did in the breakout rooms. You have cosine squared and you have a cosine. So to do this, we're going to need to move everything to one side of the equation and get it equal to 0. So the way I'm going to do it, I'm going to subtract 1 and add 2 cosine squared theta here. Subtract 1 and add cosine squared theta here. It'll kill off. The left side of the equation becomes 0. The right side of the equation is 1 plus cosine theta minus 1 plus cosine squared theta. 2, sorry, I forgot the 2 in front of that. 2 cosine squared theta. Any questions on what I've done? I decided to move everything to the right so that I could have a +2. That's why I didn't move things to the left. I didn't want a -2 in front of the cosine squared. So I just moved everything to the right. And now what I'm going to do is I'm going to reorder the right-hand side. I'm going to write it like almost in what we would consider descending order. And then I'll put equal to 0. So when you have an equation, it doesn't matter if you write 0 equals this, or if you write this equals 0, you can change the order or the side that the zero's on.
The ones cancel, right?
Did I not? Oh, why didn't I cancel the ones? Yeah, thank you. This one and that one cancel. Boom, boom. Okay. So now we have a quadratic, but look, it looks like this. It looks like 2x squared plus x equals 0, right? It's 2 times something squared plus that same something equals 0. I would have to factor this now. So how would this factor?
You can bring an x out.
Yeah, just GCF, right? You just pull an x out, be left with 2x plus 1, right? That's what we would do here. So here, I'm going to pull a cosine theta out and be left with a 2 cosine theta plus 1 equals 0. Any questions there? Because I have multiplication now, I can set each of these factors equal to 0. The first one is already solved. Cosine theta has to be 0. The second one, I have to move things around. I get -1/2 for cosine. Take the one to the other side, divide by 2. All right, now it's a general solution time. So first one, cosine is 0. Where is cosine 0? Well, cosine is the x coordinate, and that happens here and here. And those two answers are directly across from one another. So that means the argument theta must be pi/2. That's the answer up at the top, plus a half rotation, pi k. And if I get a common denominator, I get that.
Professor,
Yes.
you know how I said that it had to be sine squared theta plus to be okay? So whenever I did do the minus, I ended up getting the same answer.
You
Was that just coincidence or?
You used a different identity?
What, like I was trying to use that identity. So when I did use that, I ended up getting the same answer.
You got lucky.
Okay, I was gonna say, I don't know if that was just coincidence or.
So you replaced this with 1?
1, and then I moved the 1 over.
So then you just would have had cosine of 0, right?
Yeah, so I got cosine of theta equals 0, and then it was that.
Yeah, so you got this, but you're not going to get these answers.
Yeah, I didn't get that one yet.
Yeah, so you got lucky that you got some of the answers, but you don't get them all.
Okay.
Yeah. So on this one, cosine is the x coordinate. Where is it? -1/2. That happens here and here. And those angles are not directly across from one another, so I have to do 2 separate sets of solutions. First one is 2 pi/3 plus 2 pi k. And then the other one is 4 pi/3 plus 2 pi k. And then you could get a common denominator, right? I'm just going to leave it at this. You good? You good? Questions? No questions? All right. We're not going to be able to get through all of this. So when I do the homework solution videos, you'll see I'm going to be doing stuff we haven't done in class, but I want you to, on your homework, do as much as you can. We're not done. I want to show you another problem. I'm just trying to look at these to see which of these I want to do. I'm really disappointed that these don't, a lot of these have theta in them and they don't have like 2 theta or something like that. Let's do this one right here. But I'm going to change the problem. I'm going to make a slight modification to the problem because I want to do sine squared of 1/2 theta plus pi equals 6 times cosine of 1/2 theta. I'm changing the problem, okay? 1/2 theta plus pi plus 1. Okay, so I just use that as a template to get things set up. Let me point something out first. The argument is this, right? That's our argument. It's not just theta this time. It's 1/2 theta plus pi. All right, we need to solve this equation. So how about this? We've got a sine squared here, and on the other side, we have a cosine. How about we use the Pythagorean identity to turn this sine squared into something with cosine in it? In other words, use what we just used a second ago. Sine squared theta is 1 minus cosine squared theta. So this should turn into 1 minus cosine squared of 1/2 theta plus pi. Are you all okay on that? Equals, now this 6, I'm going to distribute it through. So this becomes 6 of these cosines of 1/2 theta plus pi, and then plus 6. So the 6 goes in front of the cosine, can't go in here, right? Because you can't multiply a number out front through into the argument. It doesn't distribute into the parentheses. It just sits out front. And then this 6 does hit the 1 and becomes 6. All right, let me get everything to one side. So I'm going to subtract 1 and add this. How am I doing on time here? Subtract 1 and add this. Gone, gone. Left side is 0. Right side is, let me go ahead and write it all in descending order now. I have the cosine squared of 1/2 theta plus pi. I have plus 6 cosine of 1/2 theta plus pi. And then plus 6 minus 1, I get plus 5. Do you all see the quadratic we have here? It looks like a quadratic with cosine. So it looks a lot like maybe like x squared plus 6x plus 5 equals 0. Where x is the cosine of 1/2 theta plus pi. So if we replace all of these cosine of 1/2 theta plus pi with x, we would get this quadratic, which factors to be x plus 5, x plus 1. Agree? Any questions? I'm going to move the 0 to the other side. Doesn't matter where that 0 is. So I'm going to put it on this side. All right, so the left side factors to be something times something equals 0. So the x first plus 5. So x is the cosine of 1/2 theta plus pi plus 5. Then the other one is cosine of 1/2 theta plus pi plus 1. Then you set each of these equal to 0. We're going to get two equations. Cosine of 1/2 theta plus pi plus 5 equals 0. And then cosine of 1/2 theta plus pi plus 1 equals 0. Still good? Any questions? This next one. Move the 5 to the other side. All right. What about the first equation? What do y'all think about this first one?
It's not a common angle, so it makes it a little bit confusing.
It is confusing because -5 is not like on your unit circle, right? Well, wait a minute. If you look at this right here, if just forget the -5 for a second. If I gave you cosine of 1/2 theta plus pi and I asked you to graph it, what would its amplitude be?
1/2.
That's going to affect the period. The amplitude's the number in front, right?
1. It'd be 1.
It'd be 1, right? And then the 1/2 does something with the period, and then the pi does some sort of left or right shift. But the amplitude's 1, which means that it has to be stuck between -1 and 1, right? When you graph it, is it ever going to spit out a -5?
No.
No. Which means there's no solution to this part of the equation. This is impossible. This can never happen. You can never have one cosine of anything and get a -5 out. Think about it in terms of cosine, and it's cosine, the range of cosine is between -1 and 1. So there's no way we're ever getting -5 out.
So that
And that's
would
why,
make
Anna
it,
Marie, when you looked at it and said -5 is not a common number on the unit circle, it's because -5 is nowhere on the unit circle, ever, right? Like here's your unit circle. This is the point -1, 0. So there the x coordinate, because we're talking about cosine, the x coordinate is -1. -5 would be out here, and that's not on the unit circle. So there's no solution there. Was there a comment or a question?
so that would make it undefined then?
That'd be no solution, that's all.
Okay.
We're just saying that there's no solution. It's like me saying this, x squared equals -1. That equation has no real solution. There's nothing you can square and get -1 unless you're talking about imaginary numbers that you're, for the most part, we don't. So we would say here, no solution, right? Same thing's happening here. We're saying there's not an answer that makes that part of the equation true. Now, what about the other part? I have to be quick here. The other part, -1 is here. It happens here, cosine, right? The x coordinate is -1, and that happens at pi, right? Or we could come around, right? Full revolutions. But it's the argument has to be that. So what I need to do is say 1/2 theta plus pi, that's the argument, must equal that angle pi plus any full revolution back to pi. And now let's solve for theta. Let's get theta by itself. I know I'm out of time. Minus pi here, minus pi here. Gone. So I have half of theta equals 2 pi k. And now I will multiply both sides by 2. I get 4 pi k. The solutions to this equation are 4 pi k, where k can be 0, 1, 2, 3, 4, or -1, -2, -3, -4. All right, we are out of time. Do your homework for this. Do as much as you can, and then I will do an extension on when it's due, because I think we'll need a little bit more time next class to just resolve some issues here, because there's some stuff with the calculator we didn't do, and so Other than that, have a good weekend, everyone.
Thank you.
Thank you.
Okay, take care.
Which lesson is this?